Hi, welcome back to my Python tutorial series. This is where we were at the end of our last video. We're using the program is Python Online Compiler, so you can just Google for that and it's the first link. Sometimes when you're programming, you want to do something pretty repetitive. So here we're printing out all the numbers from 5 down to 1. You don't have to do it over and over again. You can use loops. So what we're saying here is while a is greater than 0, print a, then a equals a minus 1. Another way of doing this, just a bit of a shortcut, is a minus equals 1. So you can see what it's done is it's gone through and it said a is equal to 5, so we're going to go through the loop. We'll print a equals a minus 1, so a is equal to 4. We're going to go through the loop. And at the end, it'll continue on. We don't have to start at 5. We can start at 5,000 and say, well, a is greater than some number. Keep going. Now, at the end of this, even though the last time we printed out a, it was 1, now don't forget your str here, because otherwise you'll get an error. Even though the last time we printed out a in the while loop, it was 1, when we failed this test, it was equal to 0. So at the end of this, a is equal to 0. We can define a list, and we can say, for an element in that list, do something. So here we've said A is a list of Bob, Sally, Horatio, Dean, and Mark. And it goes through. And the first time through, name is equal to Bob. And the second time through, name is equal to Sally. And the third time through, name is equal to Horatio. Another idea that's useful in the context of lists is ranges. So we can say, for x in range 10, print x. Now this starts from 0 and goes up to 9. So just remember when you ask for range 10, you're going to start at 0 and you're going to go to 10 minus 1. We can start halfway through the list, so we can say start at 5 and go to 10 minus 1. We can do something with those numbers. So for x in range 10, print x mod 2. What this says is divide x by 2 and give us the remainder. So we can see here we've got something going on. Let's figure out exactly what it is we have going on. So we're going to print x is equal to string of x. So x equals 0, 1, 2, 3, 4. And x mod 2 is equal to, now it's not just variables we can put in here, it's any valid expression that can be turned into a string. So we can see when x is 0, x mod 2 equals 0. When x is 1, x mod 2 equals 1. When x is 2, x mod 2 equals 0. So for all the even numbers that can be divided by 2 with no remainder, x mod 2 is equal to 0. So we could change this to x mod 3. And then we'll see every third number, x mod 3, all the factors of 3, x mod 3 is equal to 0. We can go from 0 to 9, and if x mod 2 is equal to 0, we're going to print string I is equal to 0. Sorry, we've changed to I here. So for I in range 10, if I mod 2 is equal to 0, string I is even. If I mod 2 is not equal to 0, string I is odd. So there we can see. Later on, we're going to come back to this, and we're going to calculate some prime numbers using something like this. Again, starting halfway through the list, or starting anywhere you want, and going up as far as you want. So that was pretty quick. So what's actually happening when we do this? Python's coming through, and it's going through this range 2 to 999, and it's checking this expression. So what happens when we check that expression? is Python first calculates 0 mod 2. That's 0. This equals equals is just a comparison operator. So single equals is assignment. You say A equals 1, B equals 2. Equals equals is a check. So we're saying is 0 mod 2 equal to 0? And we get a true out. Is 1 mod 2 equal to 0? We get a false. So these guys are Boolean true and Boolean false. When we say Boolean, we're talking about true and false. They're not the string true and false. So if we print is true equal to true, it'll tell us that it's not. So that's Boolean true and Boolean false. They're named after a guy who did some cool stuff a very long time ago and had all of this true-false logic named after him. So we can write a loop to check if a number is prime. Here we're going to check 7. We're going to start out with is prime equals true. We're going to go all the way from 2 up until 7 minus 1. So we don't want to check 1 because everything's divisible by 1. We don't want to check 7 because everything's divisible by itself. So we're going to go from 2 to 6. We're going to check if 7 is divisible by any of those numbers. If it is, so if A mod any of those numbers equals 0, we're going to set is prime to false. So we find out that 7's prime. We find out that 8's not prime. So what happened here? We started out with is prime equals true. First time through, I is going to be equal to 2. So 8 mod 2, 8 divided by 2 is 4, the remainder is 0. So this is going to be true, and it's going to trigger this is prime equals false. So that's how we figure out if a number's prime. Down here I've got a reminder in a comment, which starts with a hash or a pound for you Americans. If we check 1 here, it's going to tell us that 1's prime. By definition, I forgot to explain exactly what a prime is. A prime is a number with 2 prime factors. It can only be divisible by 1 and itself. So 7 is only divisible by 1 and itself. 8 is divisible by 2 as well, and 4. So it's got more than 2 prime factors. 1 by definition isn't prime because it's not divisible by 1 and another number. So you can get into semantics there. It annoys me too, but it's the definition, so I've got to stick to it. So the easiest way to do that is just to have an explicit check for when A equals 1 is prime equals false. Cool. So now we've got a way of figuring out prime numbers. We're going to revisit this later on. We're going to make it a little bit more efficient. We're going to put it in a function. We're going to do some cool stuff. Speaking of which, what is a function? So sometimes you have some code that you want to use over and over again in a program. We've just discussed that you can use loops to do stuff. The problem with a loop is you can't go off and do other things in between and use that code arbitrarily wherever you want. So here we've defined a function called say hi. Functions have these brackets afterwards because they can take arguments. We'll see that in a second. And what the function does is it prints hello. So we've got a code block here started by this colon, and everything that's indented the same amount afterwards is going to happen. So we can put multiple lines in here, and everything that's indented becomes a code block and becomes the definition of this say hi function. We can define a function that takes an argument. Now, this isn't going to work. And it's not going to work for an interesting reason. We'll go through why. So what you might expect to happen here is we define a function. We set a equal to 1. We're kind of trying to multiply a by 2 here, but we're failing. I'm just going to get rid of that typo. And instead, we're just printing out 1. What happens here is this a isn't passed by reference. We're not passing in a itself because it's a very, very simple type of variable. Python just passes in 1, not the reference to a. So instead, we need to return a function here. And when we return, we need to return a value here from the function. When we return a value, we get to store it. So what happens is Python says, okay, times 2a, a is currently equal to 1, so we're going to figure out what times 2 1 is. We're multiplying by 2 here, so this becomes equal to 2. So we can do this over and over and over again, and each time we do, a gets multiplied by 2. We can trim this down a little bit to this. We don't need that intermediate step of storing it, and it's the same thing. So how about a function to figure out if a number is even? Well, we know if x mod 2 is equal to 0, so if you can divide x by 2, and you've got no remainder, then the number must be even. So if x mod 2 equals 0, return true, else return false. So we can say a equals 7, print is even a. And we can set a equal to 8 and print is even a. So we can see, oh, got a typo there. So we can see 7 is not even, but 8 is even. Now, we can make this a little bit more simple because we know what's happening here is Python is evaluating this part. And if it's true, it's going to return this. And if it's false, it's going to return this. Well, doesn't that mean that we can just return this part here? And it works. So I've seen some people get really confused about that step that we just went through. So if this code is clearer to you for now, and you understand what's happening, and when I say, well, hang on a second, we can just return this, you get a little bit confused about what's going on, that's fine. Just do it the other way. There is absolutely no problem being a little bit more long-handed about stuff for now. While you're learning, just do whatever works for you. Don't worry too much about stylistic stuff. So those are exactly the same thing. We can use that function in a loop, and we can say for I in range 10, so this is going to go from 0 to 9, print the string of I, and tell us whether it's even. So we can see that 0 is even, 1's not, 2's even, 3's not. So we've used our function in a loop. So that's functions and loops, very, very simply. The thing that we're going to do next time is write ourselves a little bit of a non-trivial function to go through and calculate whether a number is prime or not. And then we're going to write another function that calculates all the primes under a certain number, just to really get used to how functions work.